All right, so this is section 4.6. Our objectives for today are the student will be able to use the fundamental theorem of algebra, find the conjugate pairs of complex zeros of polynomial functions, and then use Descartes' rule of signs. And so this will be a lot of stuff the same and a lot of stuff new also, or use different things. So the fundamental theorem of algebra says if f of x is a polynomial of degree n, where n is greater than 0, then the equation f of x is equal to 0 has at least one solution in the set of complex numbers. Now, we've already talked about this before, about how many solutions there are and how we can tell by a polynomial, but this is the first theorem they came up with this. Remember, when you're back in geometry, you have a lot of theorems, if-then statements or things. And so this is an if-then statement. The main thing, though, the important thing off that is this was the first thing discovered, is that if it had a degree n, there was at least one solution instead of complex numbers, which remember means real numbers and imaginary numbers. The corollary is the real important one. If f of x is a polynomial of degree n where n is greater than 0, then the equation f of x has exactly n solutions, provided that each solution repeated is counted the number of times it repeats. Now we've talked about this already, that the degree, it doesn't make any difference what comes after our highest degree. That degree tells us how many solutions we have. But sometimes those repeat and you just count it once. And so in summary, this is the important thing, and we've talked about this already. If the degree is n, then there are n solutions. Whether those are repeating solutions or not, there will be that many solutions. So if we have 7x to the 15th, there will be 15 solutions. Some may repeat, some may not. So the first thing, really easy, is they're just going to give you questions like this. How many solutions does the equation have? So when we look at this, the highest degree is 3, and so there are 3 solutions. Now, another way they can write this is how many solutions does the function have if f of x equals 4x to the 4th minus 5x plus 24. These are just, they mean the same thing, they're just written different. They say the equation when it's set equal to 0, and if it's a function, we're still just saying when does this function, if f of x is this, how many zeros does it have? And again, the same thing, the highest power is 4, so there are 4 solutions. So, the other thing they're going to ask you to do is to find all the zeros. And so they give us this function, x to the 5th plus x to the 3rd minus 2x squared minus 12x minus 8. And they want us to find all the zeros. Well, remember on the last section we found the factors. Remember p, these were our factors of p, and our factors of q, which is the leading coefficient. So our possibilities for p were 1, 2, 4, and 8. And our factors of q are 1. And so our plus or minus p over q is plus or minus these over 1, which just means it's 1, 2, 4, and 8. So that gave me the possibilities. Then we went to the Desmos graphing calculator, and we typed that in. So x to the 5th plus x to the 3rd. So remember, put in y equals x to the 5th plus x to the 3rd. And then it was minus 2x squared minus 12x minus 8. Minus 2x squared minus 12x minus 8. I think that's right. Let's check it. Minus 2x squared minus 12 minus 8. So we go here and we can look and see the zeros. And so we have 1 at negative 1 and 1 at 2. So we have 2 solutions, negative 1, negative 1, and 2. But remember, we should have 5 solutions. So that means we either have repeats or we have imaginary numbers. So what we do now is we do the synthetic division just like you did on the last assignment. And so we get, let's do -1. And it's x to the 5th, so 1. Remember, there is no x to the 4th, so I have to put a 0. And then 1, and then -2, -12, and -8. So I do synthetic division with this, bring down the 1, multiply, -1, add, -1, 1, 2, -2, -4, 4, -8, 8, 0, which is what we knew should have come out. Then we're going to do 2. So I repeat the process now with 2. We get 1, 2, 1, 2, 4, 8, 4, 8, 0. And so if we were to look at this, we have, remember, constant, first power, second power, third power. So this is 4 terms, so I could group this, pull out an x squared and get x squared, x plus 1. And I can pull out a 4 and get x plus 1. And so factoring that, I can pull an x plus 1 out of both those. So those are gone, and I'm left with x squared plus 4 for the second one. So we found another 0. So we had -1 and we had 2. We just got another -1. And now we've got x squared plus 4. So I'm going to set that equal to 0, subtract 4, and then take the square root of both sides. And so we get x equals plus or minus 2i. And so we get plus or minus 2i. Now again, I only have 4 solutions here, -1, 2, 2i, and -2i. But remember, we had -1 occurring twice. So that gave me my 5 solutions. All right? So you just have to, again, the process, if we go back to this, is to take our values of the constant and our values of the leading coefficient, put our plus or minus p over q, graph it to find our zeros that we can get from the graph, do synthetic division, and in this case, we want to go until we get down to 3, but we didn't have that. Now, if you look at the graph, when it does this and it just touches, it usually occurs twice then. So you can do that and just try -1 again and see it work. A lot of times too, if the graph flattens out like this across the point, then it's occurring more than once. So those are some things you can look at to decide if you want to try another number. But let's take a look now. And I'd like you to try these 4 problems. So on these, you're just telling how many solutions, how many zeros, and then we're going through and finding the zeros here. So try this on your own at home, then pause it to try it, then come back and see if you did it correctly. So this first one, x to the 4th plus 7x squared minus 144, the highest power is 4, so it's 4. Highest power is 3, so the number of zeros is 3. All right, so now this one, a little bit more work to do. We're going to take our factors of p, which are 1, 2, 3, 4, 6, and 12. Our factors of q are 1. So our possibilities are plus or minus these over 1. So 1, 2, 3, 4, 6, and 12. So now that we've found our possibilities, we have 3 zeros. We go to the Desmos calculator, type the equation, and we have one answer at -3 and one at -2. So our answers we know we have are -3 and -2. I'm going to do synthetic division with -3. So we have 1, 7, 16, and 12. 1, negative 3, 4, negative 12, 4, negative 12, 0. So remember, constant, first power, second power. So we have x squared plus 4x plus 4. And now you can either factor or use the quadratic formula, but I can use the x method. 4 and 4, 2 and 2. So we get x plus 2 and x plus 2. So we had our three answers. It's just that negative 2 repeated. So if we go to the next one. Now in this one you should have gotten 5 answers. Our factors of p are 1, 2, and 4. And our factors of q are 1. So we have plus or minus 1, 2, and 4. So we're going to go to the graphing calculator. Y equals x to the 5th. And then it was minus 3 plus 5. Minus x squared minus 6x plus 4 minus 6x plus 4. And so we have negative 1 and 1. Okay? Now you can see where this turns on that, so my guess is we have 2 1s, but let's check it out. So I'm going to do negative 1 first. So we had negative 1 and 1. And we're thinking we might have 2 of these. So synthetic division, we've got 1, negative 3, 5, negative 1, negative 6, and 4. So 1, 1, negative 1, negative 4, 4, 9, negative 9, negative 10, 10, 4, negative 4, 0. Let's try 1 now. 1, 1, negative 3, 6, 6, negative 4, 0. And now I'm going to try 1 again because that's where it hit that spot. 1, 1, 1, negative 2, 4, 4, 0. And so now we're left with, remember this is our constant, first power, second power, so we have x squared minus 2x plus 4. So we can try the x method, and we get 4 and negative 2, but there isn't anything, so we have to use the quadratic formula here. So we have 2 plus or minus the square root of 4 minus 4 times 1 times 4, all over 2a, which is 2. So this would be 4 minus 16. So we get 2 plus or minus the square root of negative 12 over 2. I can break this into 4 times 3. So we get 2 plus or minus the square root of 4 is 2. So that comes out front. Remember, to take care of the negative sign, we bring an I out. And then we have the 3 left inside. So the square root of 3. All over 2. And then because 2 goes into everything, I can reduce that to 1 plus or minus I square root of 3. So the answers we got were negative 1, 1. We actually have 2 1s. And then we have 1 plus or minus I square root of 3. So that gives us 4 answers. We wanted 5, but the 1 repeated. So we're okay. We have all 5 answers. So you can see the process is a lot similar to what you did on the last assignment. The difference is that sometimes you're going to get imaginary numbers. So just like before when we talked about when you have a plus the square root of b, you have its conjugate a minus the square root of b. Well, the same thing happens with imaginary numbers. Remember, the conjugate of a plus bi is a minus bi. A complex conjugate theorem says if f is a polynomial with real coefficients and a plus bi is an imaginary zero of f, then a minus bi is also a zero of f. All that's saying is if I have a, let's say, 3 minus 4i, I have to have 3 plus 4i. Or if I have 2 plus 2i square root of 3, I have to have 2 minus 2i square root of 3. So it's the same as what we had when we did radicals and we did conjugates. The same thing happens with complex numbers. So again, like we did on the when we had conjugates before and we found the equations, we're going to do the same thing here. So they're going to give you the 0 is at 2 and 3 plus I. Well, if it's at 2 and 3 plus I, then we also have to have one at 3 minus I. So remember, to get the polynomial, we do the opposite. We just take x minus that, so x minus 2, and then x minus, and then I'm going to put that in parentheses, 3 plus I, and then x minus, and then in parentheses 3 minus I, and we have to multiply that out. So again, always multiply the conjugates together. So I'm going to change this, and the first thing I'm going to do is just distribute that negative sign, so x minus 3 minus I, and x, change the signs there, well, that should be a positive 3 there. So 3 minus I, so that becomes minus 3 plus I. All right? So we want to multiply these together first. So I'm going to go x times everything. So x times x is x squared. X times negative 3 is negative 3x. X times I would be ix. I usually just put, it doesn't make a difference what order those in. It's just, usually they're done alphabetically. So now I'm going to multiply by negative 3 to everything. So negative 3 times x is negative 3x. Negative 3 times negative 3 is a positive 9. And negative 3 times I is a negative 3i. And then lastly, I'm going to multiply negative I times everything. So I get negative I times x is a negative ix. And negative I times a negative 3 is a positive 3i. And then remember, negative I times I is a negative I squared, but I squared is a negative 1, so that becomes plus 1. So now we keep that x minus 2. Now I'm going to simplify this. X squared, there are no other x squareds. I have a minus 3x, and a minus 3x is a minus 6x. I have an ix and a negative ix, so those cancel. I have 9 plus 1 is 10. And then I have a negative 3i and a positive 3i cancels. If you do that correctly, you should end up with 3 terms there. If you have more than that, you've made a mistake in your multiplication. So now that we're down to 3 terms, we can go ahead and distribute the x. So we get x cubed minus 6x squared plus 10x. Then distribute the negative 2 minus 2x squared plus 12x minus 20. And then combine like terms, so we have x cubed. Minus 6 minus 2 is a minus 8x squared. 10x plus 12x is 22x. And then minus 20. So this would be our either our function or equal to 0, depending on what they ask. Okay, they ask for a function, so equals f of x. All right, so I've got a few more here to try. You don't have to try all of these if you feel like you can do them. But do as many as you think. This, by far, is the hardest one, the last one. And so go ahead and try those and then come back and see how you did. So this first one, again, since we have minus 1, it's x plus 1. Since we have 4i, it's x minus 4i. And then because we have a complex number, 4i, we have to have negative 4i. So that would be x minus a negative 4i or plus 4i. Now again, I always multiply the conjugates together first. X times x is x squared plus 4i x. And then negative 4i times x is negative 4ix. And negative 4i times 4i would be a negative 16i squared. But remember, I squared is negative 1, so you should have gotten plus 16. So now we have the x plus 1. Those are opposites, so they cancel. So x squared plus 16. And if you multiplied that correctly, you should have gotten x cubed plus 16x plus x squared plus 16. So I'm going to go ahead and write that. It doesn't have to be in standard form. The book may ask for that. And so we're done. So that one's fairly easy. The next one got a little more complicated. So we have 3, so we have x minus 3. We have 1 plus I squared of 5, so we have x minus, put it in parentheses, 1 plus I squared of 5. So now we have to have 1 minus I squared of 5. So that would be x minus, and then 1 minus I squared of 5. So now I'm going to distribute that negative sign. X minus 1 minus I squared of 5. And then x minus 1 plus I squared of 5. So now we have to multiply this. Again, I'm going to do conjugates first. So x times x is x squared. X times negative 1 is negative x. X times I squared of 5 would be ix squared of 5. Now we're going to take negative 1 times everything. So we get negative 1 times x is a negative x. Negative 1 times negative 1 is a positive 1. Negative 1 times I squared of 5 is a negative I squared of 5. Lastly, take negative I squared of 5 times all of that. So that would give me negative ix squared of 5. Negative I squared of 5 times negative 1 would be a positive I squared of 5. And then negative I squared of 5 times this. So again, we have negative I squared. And then you have the square root of 5 times the square root of 5, which is simply 5. Remember, it would be the square root of 25, which is 5. And then I squared is a negative 1. So we get the opposite of negative 1 is 1 times 5 is 5. So there's a lot of places to make mistakes here. Make sure you're careful. But you should have gotten plus 5. So now, we've got all this. But again, we're going to simplify this. So we have the x minus 3 stays the same. We have the x squared. We have the minus x, and minus x is minus 2x. We have the ix squared of 5, and the negative x squared of 5 cancels. We have the 1 plus 5 is 6. And then we have the negative I squared of 5 and the positive I squared of 5 cancel. And so now it's fairly easy. So if you did that, you would have gotten x cubed minus 2x squared plus 6x minus 3x squared plus 6x minus 18. And so your answer should have been x cubed minus 5x squared plus 12x minus 18. And we're done. Equals f of x. So the last one, as I told you, would be the most difficult. So let's take a look at that. And the reason is we have a 2i, which remember tells us we need a negative 2i. And we have a 4 minus square root of 6, so we need the conjugate of that. We need a 4 plus the square root of 6. So I have a lot more to multiply here. So the 2 gives me x minus 2. Then we get x minus 2i. And I'm going to put the conjugates together, x plus 2i. Then we get the x minus 4 minus the square root of 6. And the x minus 4 plus the square root of 6. So I'm going to keep this the same, this the same, this the same, and I'm going to distribute that negative sign, so x minus 4 plus the square root of 6, and x minus 4 minus the square root of 6. So again, it's not hard, it's time consuming. So again, you want to multiply the conjugates together first. So these are conjugates, I would multiply those together, so I'm going to keep this x minus 2. And so I get, when I multiply this, I get x times x is x squared. Then I get a positive 2ix and a negative 2ix. We're going to cancel those. Okay, I'll go ahead and write that down. Plus 2ix and then minus 2ix. And then we get minus, now it's going to be minus 4i squared, but I squared is negative 1, so this becomes a plus 4. And then so I've got that, I'm going to leave that right now. I'm going to go and I'm going to multiply this just like we've been doing. So I'm going to take x times everything. That gives me x squared minus 4x minus x squared root of 6. And then I'm going to multiply the negative 4 times everything. So negative 4x plus 16 plus 4 square root of 6. And lastly, I'm going to take square root of 6 times everything. So I get plus x square root of 6 minus 4 square root of 6. And then remember, square root of 6 times square root of 6 is the square root of 36, which is 6. So minus 6. So now I'm going to simplify these parts before I multiply. It makes it a lot easier. X minus 2, these cancel, so x squared plus 4. And then over here we have x squared minus 4x is minus 8x. And then the negative x squared of 6 and the positive x squared of 6 cancel. And the 4 squared of 6 and the negative 4 squared of 6 cancel. 16 minus 6 is 10. And so now what I have to do is multiply these two together. X cubed plus 4x minus 2x squared minus 8. Again, I'm going to write this in standard form. X cubed minus 2x squared plus 4x minus 8. And now I have to multiply it by that. X squared minus 8x plus 10. So, to finish it, one last step, or two actually. I have to multiply everything in this times everything in that. So I have to go x cubed times everything. So x to the 5th minus 8x to the 4th plus 10x to the 3rd. Now I'm going to take negative 2x squared times everything. So negative 2x squared times x squared is a negative 2x to the 4th. Negative 2x squared times negative 8x is a positive 16x cubed. And negative 2x squared times 20 is a negative 20x squared. Now the 4x times everything. So 4x cubed minus 32x squared plus 40x. And lastly, multiply negative 8 times everything. Negative 8x squared plus 64x minus 80. And the last thing is just to combine like terms. So we've done a lot of work. X to the 5th, gone. A negative 8 and negative 2 is a negative 10x to the 4th. We have 10 plus 16 is 26, plus 4 is 30, x cubed. Then we have a negative 20, and a negative 32 is a negative 52, minus 8 is a negative 60, x squared. And then we have 40x plus 64x is 104x. And finally we have our minus 80 equals our function. So you can see there's a lot of work to do when you get to something that has that many things to multiply out. But remember we had, if you look back where we started, we had 1, 2, 3, 4, 5 factors. So we should have a highest power of 5, which we ended up with. All right, last thing. So we've gone through, we've taken the P over Q, but there's some other things we can tell by a function. Again, we used to have to go all the way through and do this without a graphing calculator, so you really needed this. But today we're going to use it just to find out the types and numbers of possibilities for solutions. So this is called Descartes' rule of signs, which as a French mathematician discovered this, René Descartes, and he lived from 1596 to 1650, so back in the 1600s he discovered this. So again, this is just a function with variables. So if f of x is written in this form, and it's a polynomial with real coefficients, then the number of positive real zeros. So if we go back, our zeros are where it crosses the x-axis. The number of positive zeros for the function f is equal to the number of sign changes in the signs of the coefficient f of x, or is less than this by an even number. So it sounds complicated, write it down, and then we'll go through some examples, and it's really not that hard to do. The number of negative real zeros of f is equal to the number of changes in the sign of the coefficients of f of negative x. So when you put negative x into the function, or is also less than this by an even number, so going down by 2's. So once, pause this, get this written down, and then I'll show you how you use it. So here's what this means. It says determine the possible numbers of positive real zeros, negative real zeros, and imaginary zeros for this function. So let's do the positive ones first. So the positive ones, all you do is you count the sign changes in the coefficients. So we start here, it starts positive and it goes to negative. So it was positive, it's now negative, that sign changed. So that's one sign change. Then it went from negative to positive, so that's another sign change. Then it went from positive to negative, that's a third sign change. Then it stayed negative, stayed negative, stayed negative. So all you're doing is counting how many times it goes from positive to negative. So positive, whatever it starts at is where you start. So it started positive, went to negative, that's 1, 2, 3 sign changes. That tells me we have 3 real zeros that are positive. Maybe. Or we go down by 2's. So there would be 3 or 1. Okay? The negative real zeros, now here this one gets a little complicated. Now what we're doing is we're putting in a negative x. So the book would have you rewrite this and put a negative sign with each of these. 6. And then simplify that to get the signs and figure out your sign changes again. It's a lot easier than that, than having to write it out. All I have to do is think of, if I put a negative x in here, if I have an even power, that's going to make it positive. So this would end up staying positive. If I put a negative in here, I have 5 negative signs. So that would be negative, but then I have a negative in front. So you're going to count the exponent, and the number of, if it's negative out front, that would be another one. So I have 5 here plus 1 outside, so I have 6. That's an even number, so that's positive. Here, I have 4 here, none out front, so that's an even number, that's positive. Here I have 3 plus 1 out front, that's a positive. Here I have 2 and 1 out front, so that's 3 negative signs, so that would be negative. Here I have 1 plus 1 in front, that's 2, so that's positive, negative. And so I have 1, and go positive, 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 negative, that's 1 sign change. Negative, positive, that's another sign change. Positive, negative, that's another sign change. So I had 3 negative real zeros. And so that goes down by 3 or 1. Now, we know because it's 6 that we have a total of 6 possibilities. We know we have, I'm going to write this up here. We know we have positive 3 possibilities, or 1, and negative we have 3 possibilities. Now remember, whatever this top number is, you go down by 2's until you get to 1 or 0. So we have 3 or 1. So we're going to just make a little chart here. We know we have 6 answers, so we could have 3 positive, 3 negatives, and that would mean we have 0 imaginary solutions. But we could have 3 positive and only 1 negative, because remember, it's either 3 or it goes down by 2. That gives me 4 answers, so I would have to have 2 imaginary, which still gives me our total has to be 6. We could have 1 positive, and we could have 3 negatives, which still gives us 2 imaginary, which gives us still 6. Or we could have 1 positive, 1 negative. That would mean we have 2 answers, so we'd have to have 4 imaginary solutions, which gives us that total 6. So you'll have to make a chart like this and show all the different possibilities you can have. So we could have 3, 3, 0, and 6. 3, 1, then we'd have to have 2 imaginary and 6. 1, 3, 2, and 6. And 1, 1, then we'd have to have 4 and 6. So that's what the last part of the assignment is. So if we look at this, so go ahead and try this and then pause it, try these, come back, and see how you did. So let's take this first one. We count the sign changes. It started positive, stayed positive, went to negative. So we have 1 positive solution. Okay? So we don't get those p's mixed up with our p and q. 1 positive. Now we put in a negative x. So 3 negatives is negative. Put in a negative. 3 negatives is negative. And this is negative. So those are negative, negative, negative. There's no sign changes. So the negatives, there aren't any. Okay? So now if I was to make the chart, if we go back, positive, we could have 1. We can't go down at all because we're already at 1. Negative, we can't have any. So that means imaginary. We know we have to have a total of 3, so there has to be 2. And that would be the only possibility you could have, because these can't go down any lower because we're already at 1 and 0. And we'd have to have 2 imaginary. So we know on this that we have 1 real solution and 2 imaginary. If we go to this one, so let's do the positive again. So it starts positive, switches to negative, that's 1. Switch to positive, that's 2. Went to negative, that's 3. Went to positive, that's 4. So we have 4, and then we go down by 2's until we get to 0 or 1. So in this case, it'd be 4, 2, and 0. Now we do the negative. So what I do is just write it up above this. 4 negatives is positive. 3 plus 1 is 4, so that's positive. 2 is positive. 1 plus 1 is positive. And so we have all positives, so there are no sign changes, so that's 0. So again, we're going to go positive, negative, and imaginary. If you want to add they may ask for the total. The total would be 3 here. So total, and you can just write it like this. So we could have 4 positive. We can't have any negatives, and so our imaginaries would be 0 and gives us a total of 4. We could have 2 2 positives. We still can't have any negatives, so we'd have to have 2 imaginary and 4. Or we could have 0 positive, 0 negative, which means we have to have 4 imaginary to get to our total of 4. And so that's how you're going to make the charts on that. So your assignment on Big Ideas Math, page 202, numbers 3 to 39, the odds. So hopefully this was helpful. Good luck.